In this video, we'll take a look at the octet rule. We are covering the octet rule during our unit on ionic bonding, but it's important to recognize that the octet rule does apply to all types of bonding. We will not cover it again when we get to covalent bonding. We'll only mention it. And if we do an intermolecular force unit with metallic bonding, again, I'll mention it. I won't go into any detail. During our last unit, we were learning about families on the periodic table. We learned that the noble gases, group number 18, are the only naturally states on the entire periodic table. They're the only elements on the periodic table that won't react with anything, that won't form compounds. What makes these elements so stable are their valence electrons. Every noble gas, with the exception of helium, has 8 valence electrons. Again, valence electrons are related to group number. Group 1 has 1, group 2 has 2. Most of the elements in 3 through 12 have 2. Group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and group 18, our noble gases, have 8. The octet rule is written around this. It states that the most stable atoms have 8 valence electrons. To understand why 8 is so important, why 8 is the magic number, we need to look back at electron configurations from our second unit. Electron configurations where we map out the potential location of all the electrons within an atom. What I have here are the electron configurations for all the noble gases. And again, helium's the odd one because helium only has 2 valence electrons. It's in period 1. It only has 1 energy level. That first energy level has only an s orbital, so it can only hold 2 electrons. All the rest, neon, argon, krypton, xenon, and radon, have their 8 valence electrons. If we look at how that plays out in their electron configurations, we see a pattern. Helium, 2s2, 2p6. Neon, 3s2, 3p6. Argon, 3d10, 4s2, 4p6. All of these electron configurations end in something s2, something p6. Again, with the exception of hydrogen. Hydrogen can't because hydrogen doesn't have any p orbitals in it. So every noble gas electron configuration ends in s2p6, and well, 2 plus 6 is 8. This part of the electron configuration is important in understanding why the noble gases are. The s and the p orbitals have relatively low energy. Low energy is what makes atoms stable. Everything in the universe wants to be in its lowest energy state. Everything moves towards low energy. Take a boiling pot off the stove, put it on the counter, and immediately it starts to cool down. On the stove and boiling, it's in a high energy state. As soon as you remove it from the stove, the energy immediately starts to drop off. Everything wants to be in a low energy state. The s and the p orbitals are that low energy state. So for an atom to have low energy and thus be stable, their outer energy level needs to contain filled s and p orbitals. Again, helium doesn't have filled s and p orbitals. All it has is a full s orbital. And the reason for that, again, it's got no p orbitals. It only has 1 energy level, and there are no p orbitals on that level.